Good afternoon, everybody, and welcome once again to another session on engineering graphics with me, Yash Chawla from Parul Institute of Engineering and Technology, Vadodara. We have come to the last two chapters of our course, and today we are going to start with orthographic projections, and then tomorrow we'll complete with isometric projections that will cover the whole of engineering graphics syllabus for the first year syllabus of Gujarat Technological University. Okay, so let's start with orthographic projection today. What are we going to study today? First, we are going to have a short introduction of orthographic projection. What are the different angles, views that are available for orthographic projection? A comparison between the first and the third angle of the orthographic projection, where what kind of views we have and what is their position, where do we have to draw those positions on paper when we are drawing our projections for the solution for our orthographic problems. And finally, we'll solve a few examples in which we'll have the application of the orthographic projections as well. Okay, first thing is that what is orthographic projection? What is the basic concept of orthographic projection? Now, as you know, ortho means perpendicular. Now, for an orthographic projection, if you want to draw an orthographic projection of any object, then first of all we have to assume that that object is kept at infinity, or the other way around, you can say it as the observer is at an infinite distance from the object. The second point of assumption is that the rays or the projection lines are going to be parallel and perpendicular to the plane of projections. As you know, if a ray of light is parallel to one plane of projection, principal plane of projection, then it will be perpendicular to the other principal plane of projection. So we'll have different views, that is front view, top view and side view. And in side view we have line, if a line is parallel to say the parallel vertical as well as the horizontal plane, then it will be perpendicular to the profile plane. So the concept applies to all the three principal planes. So first of all, let's have different views. There are two type of views in which we normally draw these projections. The first is the first angle. This is you can assume it as a cube. In previous session we had an development of surfaces, so you can assume this to be a development of surface of a cube in which there are 6 surfaces in total: the front view, the top view, the bottom view, the right side view, the left side view and the back side view. Now in this, as you can see, this is the front view of the object. Now this is the front view of the object. Now this front view is when I am looking right in front. As you can see, you are looking at my face directly from on the screen, so that is the front view. So this is where this front view lies. And when we are talking about first angle, then we have this top view and the bottom view. The top view will come below the front view and the bottom view will come above the front view. On the left hand side of the front view on your screen will come the right hand side, and on the right hand side of the front view will come the left hand side, and besides the left hand side we will have this back view, as this highlighter is showing. Then this is an example of an object which we are viewing it from front view. Now the observer is from here, is viewing from here. Now this is the object, and it's, as you can see, its shadow is being casted on the paper. Now this is the object and this is the screen. So if this is the position, then we can say that this is a first angle projection, and this is mostly in the first angle of the first coordinate system. Now as we saw in the previous slide, that this will be the front view. This is the front view of this object. This is the left view, which is from this side, and the right view, which is from this side. The right view is this side, and the top view, obviously, if you are looking it from the top. So all these things are very same, and the totally opposite in the third angle view. This is for the third angle. Now again we'll have a comparison of first and third angle, where it will be more clearer to you that what is the difference and where exactly what changes happens between the first angle and the third angle. Now here in the front view we have the top view above the front view, and the bottom view is below the front view in third angle, whereas left hand side has the left hand side view, right hand side has the right hand side view, and besides the right hand side we have this back side view of the object. So it is just like wrapping it like this and wrapping it in this way. So when you are wrapping it in this manner, say you are looking from here, this pen is the observer, you are the observer. So when I am wrapping something out, or unwrapping something, this is my hand, so this is the surface. Now this has been wrapped and this has been unwrapped, so you have looking at the unwrapped object directly, so you are looking at from the front view. Now if I turn it over, so object comes this side and this is the screen and you are the observer, I am the object. And now when I am unwrapping, then the totally opposite views will occur. This is known as the third angle and this is known as the first angle. Now similarly we will see the same example in third angle. For first angle, you viewed it from this side, the object was here and the screen was here. Now it is totally opposite, you are viewing it from this side, the object is here and the screen is here, which is totally opposite. As I said, it is, you are looking from the other side of the screen and the object is behind that screen, so it becomes third angle view. Now this is the top view, which is above the front view, and the right view is on the right hand side. This is the right view, and this is the left view, which is hidden behind this object, and the front view is exactly this is the front view of this object. So let us have a comparison of this angle. Now take a look. We have this front view. I'll take a wait a second. Okay, so I have the front view here and the front view here, so I'll take this as the reference. Okay, one sec. Okay, so this is what I have. See, this is my front view, and again this is my front view. Now it is visible on your screens, the highlighter. Okay, and now you can see the comparison. The bottom view is here. I'll mark it by an asterisk. This is the bottom view and here is the bottom view, so the totally opposite. Now the thing which was above the front view has come below the front view. On the right side, this is R. I'll mark it as R. This is R and this is L, which was left hand side had the right side view and right hand side had the left view on the first angle, whereas this has totally changed again, where left hand side has the left hand side view and right hand side has the right hand side view. The back side remains common on both the ends. The back side is here on the extreme right hand side of the figure, and the back side is again here. We don't actually use this back side in our solutions when we are doing it, but in the industry we use this solution as well. The top view is below the front view in the first angle, and the top view is above the front view in the third angle. So this is the basic difference of all the 6 views that we can have of an object in orthographic projection are become interchanged. The view which is upstairs in first angle comes down, and vice versa, and which is left on and right, they also interchange when we go from first angle to third angle. So it is very necessary that you should mention in the solution that on which angle are you drawing this solution, or else if it is mentioned in the question that you have to draw it in first angle, then you should draw it in first angle, and if it is mentioned third angle, then you should go ahead with third angle. If you interchange, the solution would be wrong, and the solution that you derive would not get you marks. Okay, now here is another example. Now it is, orthographic projection is of any three-dimensional object. Now when we are talking about three-dimensional object, then say if I talk about this mouse, then it becomes a little bit difficult for us to view or view what is actually going to happen. So what we do is we engrave this, or we enclose this mouse in a glass box. Say as shown on your screen, we have this workpiece. Now we have this workpiece, this is there. I am highlighting it on your screen. This is the workpiece. These are different surfaces of the workpiece which are there. Now this workpiece has been enclosed in this glass. As you can see, this red lines, these are all glass, these dotted lines are all glass, and this surface, this job has been enclosed right inside that glass. Now what happens is that if I want any view, now this glass box will have 6 sides, and once this object, that is my job, is been enclosed in this, when I move my glass, glass box, the object will be moving along with it. So if I want to see the front view, as here, yes, as you can see here, yeah, as you can see here, when I want to see the front view, so what I'll do is I'll turn the glass this way around, and this thing will be in front of me. So this is my front view. Now when I'm looking at the front view, this whole section is the only thing that I'll see about the object. That's why it is necessary that when I'm looking at the frontal view, I'll get my front view. Now at the same position, if I change my position and go on the side, this is what I will see. This is what I will see from the side when I am viewing it from here. This is, I am taking it as a side view, and this section is depicted this way in this box. This slant section is being depicted by this box, and this vertical line segment, vertical lines that you are seeing are shown by these this section. So my side view is clear. Now if I move to the top view, then I have what views do I have? This whole section, that is say a type of polygon, is visible on the top view here. So on the glass surface, I'll be able to view this rectangular surface, or say this rectangle on the front view is drawn here, and if I get this another rectangle which is shown here. So you can see that all the 3 views that I need, if an engineer, the person who is making a job requires this 3 views, and when I get these 3 views, I'll be able to get my object. Now without giving this 3-dimensional object to the operator, if I give him these 3 views that are there, this is 1, this is 2, and this is 3. So if I give these 3 views and I tell him that this is my front view, this is my side view, and this is my top view, he will be able to generate this piece without having a 3D model, actual 3D model of it in front of him. That is what the interpretation power is of this orthographic projection. Now as I told you, when we draw it on paper, it is something of this sort. Now these points are extended on the frontal view, and we get this solution from the object. Now if I talk about the whole view, and this is a I like to mention here that this is we are talking about third angle. This is the third angle projection, where the top view is above the front view. This is the top view, this is the front view, and this is the side view that we have. So this is when I unwrap this cube and have these surfaces visible on a single plane of paper, then I have this third angle projection. If I would have done it the other way around, where the top view comes below the front view and the side view remains on the side, then it would have become first angle. Now let us go on to solving a few examples. Today we will be solving 3 examples, and let's see how. We'll start with simple examples. Now I would like to mention here that I have not mentioned dimensions, and I have not mentioned the figure labelings of the figure, because the figures on the presentation would have not been clear for your visualization. Whenever you are attempting any figure, any solution for an orthographic projection or any engineering graphic solution, you should always remember 2 things. One is that all the dimensions should be noted down on the sheet where you're giving the solution, and second, all the points that you have mentioned that are mentioned in the question, and if you're assuming any points, then all the points should be static on all the drawings that you're drawing on the paper. If you fail to do so, the solution cannot be a perfect one, because say if I take a point A here and now I'm taking another point, I'm not naming it, it might be the same point, it might not be the same point. So for a operator to interpret that point, he has to know that this is A and this is also A. So he will be able to interpret that yes, this is the front view, this is the side view, and this is the top view. Okay, for this solution, the first example is given in form of a figure. Now here you will be given a figure and you will be given dimensions, as well as if labels will be given. If labels are not given, you should assume the labels, you should and you should draw your solution. Now say you can say a stairs kind of a figure is given to us, where these different colors have a significance. Now when the three views would be, the observer is from here, so this is the front view. Now if the observer is here, then this would be the top view. I'll write it again, this is front view, and this would be the side view. Okay, now as you can see, I have used three shades here, or the image from where I have taken it, I have taken this image has used three colors. One is pink, and this is light pink. This is light pink, and this is light green, and this is a little darker green. This is light blue, and this is dark blue. So basic concept that is been followed in this figure is that if the surface is closer to the observer, then the color would be lighter, and when it is going away from the observer, the color becomes darker. So when you look at this cube, or say when you look at this job from different angles, that is when you look at it from the front, when you look at it from the side, and when you look at it from the top, if you see green color from the top, then that is your top view. When you see blue color from your side, that is your side view, and when you see pink color of any shade, pink color of any light or dark shade, then it is your front view. Now I have taken a small animation, and in the next the animation will do the drawings, and then I'll explain you that what basically happens and how the different views are there. Now for front view, see these lines have been extended and you get the front view. Let this figure complete and watch it carefully. Okay, so this figure